Hi, welcome to Section 9.2, Introduction to Circles. Our objective is going to be to begin working and solving problems that involve circles. For homework, we're going to work on page 374 to 376, 1 to 17. So the first thing we need to talk about is what the circumference of a circle is. Circumference of a circle is defined as the distance around a circle. It's kind of like a circle's perimeter. Circumference is found by taking the diameter times pi. The area of a circle is the amount of space that a circle occupies. Area is equal to radius squared times pi. So let's do a couple examples where we're going to find the area and circumference of the circles with the given information. So for our first one, to find the circumference is going to be the diameter 8 times pi, and we're done. For our area, we need to find out what the radius is. A radius is half of the diameter. So take the diameter divided by 2, and the radius is equal to 4. Radius squared pi is going to give us 16 pi. For our second one, we know that the radius is 4, so in order to plug it into our circumference formula, we're going to need to double it. So the diameter is 8. And just like in the last one, the circumference is going to be the diameter times pi, and the area is going to be the radius squared pi, which would be 16 pi. For our next one, circumference is the diameter times pi, so 9 pi. But for our area, our radius is going to be half of the diameter, which is 4.5, and let's plug that in. 4.5 squared times pi. That gives us 20.25 pi. For our next one, our radius is 3.25, which means the diameter, when we double that, is going to be 6.5. Therefore, the circumference is going to be 6.5 pi, diameter times pi. And for our area, it's radius squared pi, which is going to end giving us 10.5625 pi. Our last example. Our radius is the square root of 5. If we double the square root of 5, we get 2 square root 5. That's going to be what our diameter is going to be. So here we go. Circumference is going to be the diameter, 2 root 5 times pi. And for our area, it's going to be my radius squared pi. Squares and square roots cancel each other out, so the area is going to be 5 pi. Next, we're going to talk about arc measure and arc length. Arc measure is the measure of an arc in terms of degrees. An angle's arc measure is equal to the measure of the central angle, so an angle whose vertex is at the center of the circle. Arc length is a fraction, or a piece of the circumference, not the distance all the way around, but just a fraction of it. So for our first example, a circle's radius is 6 centimeters. An arc AB is 1/4 of the circle. Find the length of AB. So we're looking to apply our arc length formula. Well, let's look at what that would look like. Here's a circle whose radius is 6. Now, we can find out what the circumference is, the total distance around the circle is, by taking the diameter, which would be 12, and times pi. Now, they said that AB is only 1/4 of the circle, so its length should just be 1/4 of my circumference, which would be 3 pi is going to be the length of arc AB. For our next example, we want to find the measure of arc CD and the length of CD. Let's see what you can do. Press pause and give it a try. So first and foremost, the measure of CD. If we look at where C and D are located, and where the vertex would meet, it meets at the center. We have a vertical and a horizontal line, and we know those are going to form right angles. If our central angle is 90 degrees, the measure of arc CD is also going to be 90 degrees. Next, we have the length. So let's find the circumference around the whole circle. It's going to be the diameter, the distance all the way across, which is going to be 8 pi. but we only want CD, which is going to be 1/4 of our circle. So we're going to take our circumference, times it by 1/4, and that gives me 2 pi is going to be the length of arc CD. Now we move into a sector of a circle. A sector of a circle is a fraction of the circle's area. So for our example, we're going to find the area of the sector. Now, the area of the total circle is going to be radius squared pi. So 7 squared pi is going to be our area, which is 49 pi. That would be if everything was shaded in, but it's not. Only 1/4 of my circle is shaded in. So I'm going to take 1/4 of 49 pi to get the area of my sector. My area would be 12.25 pi. It's going to be the area of the sector. Next, we're going to talk about an inscribed angle. An inscribed angle is an angle that's inside, and an angle whose vertex lies on the circle rather than at the center of the circle. The measure of any inscribed angle is 1/2 of its intercepted arc. The intercepted arc is going to be the arc that lies in between the angle's ends. So our arc here is 80 degrees. We want to find the value of x. If our arc is 80 degrees and we have an inscribed angle whose vertex is on the circle, all it's going to be is 1/2 of its arc, so the value of x is going to be 40. Now here's one for you to try. If Jn is the diameter of circle O, what's the coordinate of O? Press pause and let's see if you can figure it out. Well, if they tell us that we have circle O, they're telling us what the center of the circle is. If Jn is going to be our diameter, its endpoints are at -2, -5, and 8, 5. What we want to do here is we want to find the midpoint. The midpoint is the halfway point of our diameter, splitting it into 2 radii. To find a midpoint, add up the x's, chop them in half, add up the y's, chop them in half. That gives me 6 divided by 2, which is 3, and 0 divided by 2, which is 0. The coordinates of O are at 3, 0. And it's time for our last example. I know, short video, nice. We're going to show that triangle INS is a right triangle by finding the measure of angle INS and by finding the slopes of IN and NS. Now, the measure of angle INS. Angle INS is actually an inscribed angle. It's an angle whose vertex or center point lies on the circle. Its endpoints lie on the diameter, which means that its arc is going to be 180 degrees. Therefore, my angle is going to be 90, 1/2 of my arc. The second way of showing it's a right triangle is to look at the slopes, and let's compare that as well. So let's look at our slopes of IN. Our slope formula is going to be y2 minus y1 over x2 minus x1. So here we go. y2, 8 minus y1, 0 over x2, 6 minus x1, -10. And 2 negatives make a positive. 8 over 16 reduces to 1/2. Now let's look at NS. Same formula. y2 minus y1 over x2 minus x1 gives me -8 over 4, which reduces to -2 over 1. When we look at their slopes, we see that we have opposite sign reciprocals, meaning that we have right triangles. So here's the answers to our homework. Again, it was 1 through 17. Do the best job that you can, and if you have any questions, please make sure you bring it to class tomorrow. And as always, have a good one.